So hello everybody, we are solving a quick question here. You may take a pause, look at this problem, think of a solution of this problem, or otherwise you can see through the solution, no problem. Let's get started with the problem. The problem is stating one end of an elastic cord is attached to the block of mass m and the other end is held keeping the cord relaxed and vertical. The relaxed length of the cord is L and there is a mark P at a height 0.8 L from the lower end. If the upper end is slowly raised, the block leaves the ground. When the mark P reaches the point where the upper end of the relaxed cord initially was, what is the expression for the work done by the force applied by the hand? And we have four options. So I'm giving you a hint, maybe you can look at the hint and then solve for it. Draw a necessary diagram, try to understand how the point P move, calculate for the elongation and then try to get the answer, or otherwise let's get going. Okay, I'm giving you the solution to this problem. So this is the necessary label diagram which is needed to solve this problem. So you can use this as a hint also and then again take a pause to solve it yourself. So over here what we have done, so this is the initial condition which we have drawn where the block is originally on the ground and this is the elastic cord which we have. Now a force is applied over here so as to gradually pull it up in the upward direction, and then as the elastic cord is undergoing elongation, the point P reaches from here to here because every strata of this elastic cord is undergoing elongation, and as a result of which P, which was initially here, reaches here, and the length of the elastic cord becomes LF, but point P is still going to be 0.8 times of LF because every point on the elastic cord is undergoing elongation. So using this hint we are going to solve this problem, that the length L is equal to 0.8 LF, and this is going to become my first equation, that 0.8 times of LF is equal to the original length L, and hence from here if we calculate the LF, so we can say it is equal to 10L by 8, or we can say 5L by 4. So the final length is 5 times L by 4, and this is going to serve as the first equation for this problem. So if I calculate the elongation in the elastic cord, so elongation in the elastic cord is L final minus L, and over here we get 5L by 4 minus L, that is a value equal to L by 4. So this is going to serve as the second equation for this problem. Now the next important hint that we have is that the block is lifting off. So at lift off, we can say that the elongation produced K delta X, the force will be produced is K delta X, and this is balancing the weight mg, and over here we can say the value of K can be calculated. So K times of delta X, that is L by 4, is equal to mg, and from here we obtain K as 4 mg upon L. So this becomes the third expression for this problem. So at lift off, this is the condition, and now we are calculating the work done by the external applied force to get the final answer. So therefore work done by external applied force, and here we obtain work done is equal to half kx square, and if we substitute the values, that is half k can be written as 4 mg by L, and then elongation squared, so elongation squared will become L square by 16. So over here we get the answer as mg L by 8. So on solving we obtain this answer mgl by 8, and if we look at the options that is given to us, so we get alternative B. So alternative B is correct. In case you got it correct, amazing. Otherwise I hope you can easily understand the problem now. So these kinds of problems are the new ones which are there, and we need to solve through them, understand the concept. The moment you draw a necessary diagram, you will be figuring out that this L is equal to 0.8 times LF, and every strata of the elastic cord is undergoing elongation uniformly. So I hope you understand the problem, like the content, do continue to watch, but continue to solve on your own also. It is important that you just don't end up giving views to the YouTuber. It is very important that you solve it yourself, solve a large number of problems yourself, and continue to watch, like, share and subscribe.